Welcome back, everybody. In this video, let's talk about research report number 3. So from our Blackboard course website, go ahead and click on Project Info. Then go ahead and scroll down a little bit until you see research report presentation number 3. So for this group project, and most groups typically consist of 3 students, you will collect data from 3 separate groups and then compute a one-way ANOVA using the skills that you've learned in class and of course using SPSS. Above you can see I've posted 3 different files. One is an instructions file, we'll look at that very closely. One is a grading rubric for the research report, we'll look at that as well. And another is a grading rubric for the presentation that you will do. I have a separate video regarding the presentation, so we'll just focus on the analyses and the research report in this video. Let's get started by looking at those instructions. This section right here talks about this project being listed in the homework packet. So if you want to look at the homework packet and get some more information, feel free. But everything you need to know, we're going to cover in this video. So what you need to do is pick an independent variable and a dependent variable. Remember, the independent variable is our grouping variable. And we're trying to learn more about analysis of variance. And remember, we use an analysis of variance when we have 3 or more groups that we're comparing. So we want that independent variable, that grouping variable, to have 3 different groups. And the independent variable that I selected was political group. So I'm looking at differences between independents, Democrats, and Republicans. And I need to see how they differ based on some type of dependent variable. So you'll need to pick a dependent variable as well. And the dependent variable that I chose to pick, I asked people how optimistic they were about our country's future using a 10-point scale. Once you've selected an independent and dependent variable, you're ready to collect data, and you want to collect data from 15 people in each group. So in the end, you should have 45 pieces of data. All right, next let's scroll down and figure out what we're going to do once we have that data. So in your research report, you'll begin like you've begun in the other research reports by writing an introduction. Look through this section very closely. Make sure you talk about each one of these points. Remember, when you're writing your report, you should number and letter each section so that you've covered all of your bases and so that I can find your information very easily. In section 2 of your report, you'll identify your independent and your dependent variable. That should be very straightforward. Then in section 3, you're going to identify and discuss the 3 assumptions regarding analysis of variance. You'll want to test each assumption using methods that we've discussed in class. We'll go over that in a minute. You want to discuss if you violated any of those assumptions, and make sure you explain this in sufficient detail. This is really a very important section. Let's scroll down just a little bit. In section 4, you're going to conduct the one-way analysis of variance using an alpha of 0.05. Be sure to read those instructions very carefully so that in your report you include all the necessary information. I'm going to focus right now on what we need to do with SPSS. So for example, using SPSS, conduct a one-way between groups ANOVA. Include the SPSS source table in your report. I'll remind you how we can copy the output from SPSS and put it into our Word file. From SPSS, also include a table with group means and standard deviations, variances. I'll show you how to do that. In section 5, it says using SPSS, perform Fisher's LSD test, whether it's appropriate or not. Remember, we typically do post tests only when we have a statistically significant analysis of variance. Some of you will, some of you won't, but I want all of you to do the Fisher's LSD test just so we can get some experience doing that. I'll show you how to do that. And then in section 6, it says using the SPSS output from your ANOVA source table, compute the effect size, which is eta squared. I'll show you how to do that. The good news is that we can do all of this in just 2 data runs. We can get this done very quickly with SPSS. So let's get started. All right, my friends, I've already opened up SPSS, and you should know how to do that by now. You might be in a computer lab on campus, or maybe you're at home using OU's virtual desktop. Either way, open up SPSS. The first thing you need to do in SPSS is set up your data file. You're going to have a new data file based on the new data that you've collected. I've already shown you how to create a data file in research report number 1. If you need to go back and look at that for more detail, feel free. But let me give you a very brief refresher right now. The first thing we need to do is go to variable view because we need to declare the different variables that we've collected data for. So click on variable view. All right, let me remind you real quickly how to set up your different variables. My independent variable was political affiliation. I'm just going to call the variable politics. Once I type that in and I hit enter, SPSS will automatically populate most of those fields. SPSS creates a numeric variable for me, and that's what I want. And I have an opportunity right here to put in a more appropriate label. So I'm going to put in a label that's called political affiliation. Remember, when you label things up now, all of your output will come out labeled. So it's definitely something you want to do. In my data set, I'm going to put a 1 if somebody's a Democrat, a 2 if somebody's a Republican, and a 3 if somebody is independent. There's nothing intuitive about those numbers being paired with those names. So I need to declare that in the value label section. So click on that and then click on the ellipsis. Now we have an opportunity to associate values with labels. So when I put in a 1 in my data set, that's actually going to represent Democrats. I'm going to add that to my list. When I enter in a 2 in my data set, that's going to represent Republicans. I will add that to my list. And then when I put in a 3 in my data set, that's going to represent independents. And we will add that to the list. All right, once you have everything that you need in your list, click OK. While we're here, we might as well declare our measurement scale as well. This is a nominal measurement scale. We just have names of categories. Real quickly, let's set up the dependent variable. Regarding the question I asked, how optimistic are you about our country's future? So I'm just going to call that variable optimism. Like before, SPSS will automatically create a numeric variable. That's what I want. I'm going to give it a more appropriate label. I'll label it how optimistic about our future. People responded to that question using a 10-point scale where higher numbers represented more optimism about our country's future. So there's no need for us to declare value labels. Okay, once you have your variables set up, you can click on Data View and then start entering your data. Here's my data file. I've already entered all of my data. So you can see that I have 15 pieces of data entered for the Democrats, 15 pieces of data entered for the Republicans, and 15 pieces of data entered for the independents. So I have 45 lines of data overall. Let's look back at our instructions for a minute and remind ourselves what we need to do. In section 3 of your report, you had to identify and discuss the assumptions associated with ANOVA. Some of that stuff needs to be tested, so we can do that with SPSS. For example, one of the assumptions might have to do with the shape of the distribution, whether the data is normally distributed or not. I can look at each group and see if that dependent variable, optimism about our country's future, is normally distributed. So what I need to do, and this should sound familiar because you did this for Research Report 1 and Research Report 2, I can split the file and then look at histograms for each group. So let's go ahead and do that. To split the file, we're going to go to the Data menu, and then all the way near the bottom, there's an option for Split File. So click on Split File. Keep in mind why we are splitting the file. We want to have our output organized by different groups. So I'm going to click right here on Organize Output by Groups, and I want those groups to be based on political affiliation. SPSS realized that political affiliation was a grouping variable, and it was my only grouping variable, so it stuck that in there by default. So that's everything that I want. I'm going to go ahead and click on OK. Your output window will open up, and you'll see the commands that SPSS used to split your file. And I don't really need to see that anymore, so I'm just going to click on it to highlight it, and then hit my delete key to get it out of my way. Let's go back to our data editor window. I'm going to click on Window and go back to my data file. The thing that I want to check for right now, I want to check all the way down here. Do you see where it says Split by Politics? Now I know my file is split. All right, so I want to look at histograms for each group. Let's go to the Analyze menu. Let's hover on Descriptive Statistics, and then let's select Frequencies, because we know when we select the Frequencies command, we can get histograms. I don't necessarily need frequency distribution tables right now, so I'm going to turn off that option. I'm going to go to Charts, and I'm going to click on Histogram, and I'm going to put a check mark where it says Show the normal curve on the histogram. and then I'm going to click on continue. And then, of course, I need to tell SPSS which variable to create these histograms for. And that's going to be my dependent variable, how optimistic the people are about our country's future. Once I do that, I can go ahead and click OK. Go ahead and scroll all the way to the top, and now you can look at your histograms. So here's the histogram specifically for Democrats. Down here is the histogram specifically for Republicans, and you can see that doesn't look normal at all. That's clearly skewed. That would be negatively skewed. And here is my histogram for the independents. That doesn't look too bad. That's probably the most normal distribution I have of the three. So you can look at your own data and determine for yourself if you have violated this normality assumption. And remember, you can include these graphics in your report and in your presentation. I'm just going to highlight that graphic. I'm going to right click. I'm going to say copy as image, and then I'm going to paste it into my Word document. Let me remind you how to do that. Here I am in Word. I copied that histogram as an image file. So at this point, I should be able to just click on paste, and there it is. And remember, you can click on that, and then you can resize it because it's really just a picture. It's not a graph anymore. All right, let's go back to SPSS. We are about to run our analysis of variance, and I don't want all of this output cluttering up my output window. So I'm going to hit Control A to select everything, and then I'm going to hit my delete key to get everything out of my way. Let's go back to our data editor and look at our data file. Keep in mind, our data file is still split by our independent variable. In my case, it's split by the different political groups. I want to turn that off because when I run the ANOVA, I need all of that information put together. So just go to your data menu. Again, select split file. But this time we want to click right up here where it says Analyze All Cases. Do not create groups. What it's going to do is turn the split file off. So go ahead and click on OK. Your output window will open up and it will show you that the split file option has been turned off. We don't need to see that anymore, so I'm going to highlight it and then hit my delete key. Now I'm going to go back to my data window. All right, so here is our data file. Now we're ready to run the analysis of variance. Remember, when you need to do an analysis, a good place to start is by looking at the Analyze menu. With an analysis of variance, we compare the means of 3 or more groups. So come on down here to where it says Compare Means and just hover. And then you'll see an option way down here, One-Way ANOVA. That's what we want. Go ahead and click it. Let's begin by telling SPSS which variables we're using. The factor is the grouping variable that we have. That represents the different groups that we're comparing. So clearly this variable right here, political affiliation, would be my factor. Dependent list is where I list the dependent variables. We just have one dependent variable, and that is how optimistic the people are about our country's future. So I'm going to click on that and then move that over to this list. Let's go ahead and check and see what our options are. Click on Options. We have one option to get descriptive statistics, and according to our instructions, we needed to include means and standard deviations for the groups, so we want that. SPSS will provide us with a nice table. Remember, another thing that we need to do is test, when possible, the different assumptions for the analysis of variance. And one assumption has to do with homogeneity of variance, the equality of the variances between the groups. So I can do that with SPSS. We might as well make use of that. So click on Homogeneity of Variance Test. That should be everything that we need in this options menu. So then just go ahead and click on Continue. You might recall that in the instructions it stated whether or not you have a statistically significant analysis of variance, you should conduct the Fisher's LSD Posttests. So we can get that right here from this screen. You see that there's an option for post hoc. This is how we can select the different post hoc tests, the post tests. So go ahead and click on that. And at this point, we can select Fisher's LSD Posttests. So click that and then click on Continue. You also might recall that in our instructions, we were asked to compute the effect size eta squared. And right here, there's an option for estimating the effect size for the overall analysis of variance. So virtually everything that we need, we're doing right here in this one shot. So let's go ahead now and click OK, and SPSS will run our analysis of variance. All right, here's all of the output that we requested. Go ahead and scroll all the way to the top. You'll see here are the commands that SPSS used to run that analysis of variance. Click on it to highlight it, and then hit your delete key to get it out of your way. The first table that I see right here is the table of descriptive statistics. And of course it has lots of information. We'll include that in our reports and in our presentations. It shows we have 15 people in each group. The groups are labeled because we set up our data file that way. And here when we just look at the means, we can see that the independents were the most optimistic. It looks like the Democrats were in the middle and the Republicans were the least optimistic. We're trying to determine, are these the types of differences that we would expect just by chance, just due to sampling error? Or is it very unlikely to find those differences just due to chance? And in other words, do we have a statistically significant result where these sample group differences represent real differences in the population? That's what we're trying to determine. Let's continue to discuss our output as it's presented in this window. So the next thing that we see is the test for homogeneity of variance. Remember, one of the assumptions of analysis of variance is that the different groups that we're comparing have approximately equal variances. If they don't have approximately equal variances, the validity of our test comes into question. So remember, this is a test for something bad. We don't want it to be statistically significant. We want everything to be okay. So let's focus on that first line where it says it's going to do that test based on the mean. And it's giving me Levene's statistic right here based on 2 and 42 degrees of freedom. And right here it tells me the significance level of the test. Remember, that is a p-value, that is a probability value. And we just compare that with our alpha level. If that probability value right there is less than 5%, then we have a statistically significant test. That would mean we violated the assumption of homogeneity of variance. If that value is not less than 5%, then that would mean we do not have a statistically significant test. We did not violate the homogeneity of variance assumption. And in this case, the good news is we did not violate the homogeneity of variance assumption. Just look at those first two numbers to the right of the decimal place. We see 0.41, so that's like 41%. 41% is clearly not less than 5%. This is not a statistically significant result. We do not have a problem with the assumption of homogeneity of variance. Well, that's good news. Let's go ahead and move down a little bit and look at our ANOVA table. This ANOVA source table should look familiar. It's structured just like we structure them when we create them by hand in class. For this particular test, you can see that we have 2 and 42 degrees of freedom, and you can see that the F value is 9.20 approximately. Well, that's a relatively large F value. And one thing that this table from SPSS has that we're not able to compute very easily by hand is the exact significance level. That is the p-value. Now remember, we want to compare that with our alpha level of 5%, 0.05. Now there we see a p-value of 0.000. Now that value is not actually 0. Somewhere out several more decimal places there is some number. But again, just look at the first two numbers to the right of the decimal place. I see 00. That's 0%. Is 0% less than 5%? Yes, it is. So this is indeed a statistically significant result. I do indeed have statistically significant differences somewhere among the three groups that I compared. Remember, that's all that this omnibus analysis of variance tells us, whether or not group differences exist. If they do exist, like they do in this situation, we need to compute post-tests to find out which groups differ from one another. While we're here, while we're looking at that table, let's talk about how we would summarize that ANOVA. We computed an F test, an F ratio for that ANOVA with 2 and 42 degrees of freedom, and the F value was equal to 9.20. And the probability value is less than 5%, showing that it's statistically significant. The next thing that SPSS provides for us in our output is a measurement of the effect size. So let's go ahead and talk about that real quickly. We in our class like to focus on eta squared. Remember, eta squared just represents the proportion of variance accounted for, and it's very easy to compute. all we need to do is take the sum of squares between groups and divide by the sum of squares total. Let's just do that real quickly. Sum of squares between groups is equal to 18.978. I want to divide that by sum of squares total, which is 62.311. Remember, sum of squares is the basis for variability. So we're essentially looking at the variability between groups as a proportion of the variance total. So that's why we call this the proportion of variability accounted for. It's the proportion of total variability accounted for by the political groups. So once I hit enter, I see 0.3045, and that would round to 0.305, just like we see in the SPSS output. So in this case, about 30% of the variability in optimism scores can be explained by a person's political affiliation. All right, let's scroll down just a little bit. Here we see our post tests. This table shows the results of our Fisher's LSD post tests. It's probably the most confusing table to look at and make sense of. There's actually quite a bit of redundancy in this table. Let me explain. So right over here, this shows the differences that exist between the Democrats and the Republicans. And there's a difference between the group means of just about 0.4. In this case, it's showing that the Democrats are a little bit more optimistic than the Republicans. Let's go down one line. You can see that this is comparing the Democrats and the independents, and it's resulting in a difference of about 1.13. This is showing that the Democrats are about 1 point less optimistic than the independents. The reason why I said there's some redundancy in the table is because each of those two lines right there is actually repeated in another spot in the table. Because look at this first line again. This is comparing Democrats and Republicans. Well, look at this section right here. It's comparing Republicans with the other two groups, and this part right here is comparing Republicans and Democrats. So this analysis on this row right here, this line right here, is going to be the exact same analysis as this row, as this line right here. So the table has some redundancy. It's actually about twice as big as it needs to be. But a lot of people find this helpful because this is comparing the Democrats with all other groups. This is comparing the Republicans with all other groups. And this section right here is comparing the independents with all other groups. So we just need to accept it. This is the way SPSS is. Let's look at the columns and make sure we understand what they are. This first column right here is showing the mean difference, literally the difference between the two means for the two groups. You might recall that to compute Fisher's LSD, we have to look at that mean difference, and then we need to divide by the standard error. And the standard error will be the same for all of those group comparisons that we make. That's why you see the same standard error value for each line in that table. And then it's this next column that has really quite a bit of information. That's telling us if that particular analysis, if that particular comparison is statistically significant. And that is showing us an exact p-value, an exact probability value. And we want to compare that value with our alpha level of 5%. And just like always, if we see a value less than 5%, then we know it's very unlikely to find those differences just by chance. And we know that we have statistically significant results. So let's look at the first comparison. In this first row, we're comparing Democrats and Republicans. 0.28 or 28% is not less than 5%. That is not a statistically significant difference. The difference between the Democrats and the Republicans is the type of difference we would expect to find by sampling error. Let's move down one row. Here I see a value of 0.00 if I just focus on the first two places after the decimal point. Is 0% less than 5%? Yes, it is. That is a statistically significant result. When we look at the mean differences, we can see that this analysis is showing that the Democrats are less optimistic than the independents. So stated another way, the independents are more optimistic than the Democrats. And do you see right there where it shows the mean difference? There's an asterisk. If you look way down here, it says the mean difference is significant at the 0.05 level. So it's flagging it for you. It's letting you know that's a statistically significant result. So anywhere where we see a p-value, a significance level less than 5%, like we see right there, we have a statistically significant result. Now don't forget, I said there's some redundancy in this table. If this row right here represents the difference between Democrats and independents, then right over here in this row, we see the difference between independents and Democrats. It's the same thing. And that's why we see the exact same p-value listed here as well. So in your own mind, make sure you can minimize things the way that I just did. Each row that we see has a companion row that has the exact same information. Let's continue to look at our results. This row right here shows the difference between the Republicans and the Democrats. It's the exact same row as this first one. We know it's not statistically significant. The Democrats and the Republicans do not differ. Let's go down one more row. In this row right here, we're comparing the Republicans and the independents. I see a p-value of 0%. Is 0% less than 5%? Yes, it is. Right there, we have a statistically significant result. And that's showing that the Republicans are statistically significantly less optimistic about our country's future compared to the independents. Let's move down and look at these final two rows. We've actually seen them already. This one is comparing the Democrats and the independents, and then the one below it is comparing the Republicans and the independents. We've already seen those comparisons above. But one thing that's nice about this particular section is that's where we found the statistically significant results when we compare the independents with the other two groups. When we compare the independents with the Democrats, they are more optimistic and it's statistically significant. When we compare the independents with the Republicans, they are more optimistic and that result is statistically significant. So that final section of the table summarizes things pretty well. Let's revisit our instructions and make sure we have everything that we need. For section 4, we did compute our analysis of variance. For section 5, we computed our Fisher's LSD. It also asks what critical t-value and degrees of freedom do we use for that LSD test. Let me just remind you of that. Although SPSS does not report the actual LSD value, we could find it by taking the difference between the two means and dividing by the standard error. That would give us the t-value. Once SPSS computes that LSD value, it compares it to a critical value and computes that probability so that we can determine if it's statistically significant or not. If we wanted to find out what that critical value was, we would need to look it up. And remember, when we do the LSD test, we're doing a t-test with 42 degrees of freedom in this case, because we use degrees of freedom within groups from the omnibus analysis of variance. Let's look up that critical value. Here is a t-table showing all of the critical values that we need based on different degrees of freedom. This is based on a two-tailed test with an alpha of 0.05, so this is the column that we're interested in. We need to find the closest thing to 42 degrees of freedom. Here's our column for degrees of freedom. The closest thing that I see to 42 would be 40 degrees of freedom. So if I move out to the right for this row, and I meet up with that column that we identified before, I see that the critical value would be plus or minus 2.021. So that is the critical value that we would need for the Fisher's LSD test to be statistically significant. Here I am back at the Fisher's LSD output table. Remember, this test right here that I'm pointing at compared the independents and the Democrats, and it was found to be statistically significant. Let's just prove to ourselves why it's statistically significant. Let's actually compute the Fisher's LSD value based on the information that we see in that output table. In order to compute Fisher's LSD, we first need to look at the difference between the means. And according to that table right there, it says the difference between the two group means for the Democrats and the independents is 1.13. So I'll put that into the calculator, 1.13. Now we simply need to divide that by the standard error. And the standard error is listed right there in the table, 0.3709. So I divide by 0.3709. Hit enter. That value, the Fisher's LSD value, is about 3.05. We need to compare that to our critical value. We just looked it up. The critical value is equal to 2.021. So clearly, this Fisher's LSD value exceeds the critical value, and that's why we have statistically significant results. Here we are back at the instructions. It looks like everything that we needed to do with SPSS we've done, so we have all of that covered. For section 7, you'll need to write up your conclusions. Remember, this is the time where you want to summarize everything that you found overall. In general, what's the story of your data? In general, what did you learn about the groups that you compared? And finally, make sure you take some time to look very closely at the grading rubric. It's always smart to know how you're being graded. For every section of the instructions, there are points associated with everything I'm asking you to do. Make sure you do all of those things so that you can maximize your points on this project. Good luck, everybody. If you have any questions, just let me know.